Medical news at HBMS TV. Studies have shown that tiny sugars in the brain disrupt emotional circuits, fueling depression. Depression is a serious disorder that disrupts daily life through lethargy, sleep disturbance, and social withdrawal, and also increase the risk of suicide. The number of depression patients has steadily increased over the years, affecting more than 280 million people worldwide as of 2025. Now researchers have uncovered a new pathological mechanism that could provide clues for the diagnosis and treatment of depression. A research team led by C. Justin Lee and Lee Boyang at the Institute of Basic Science has identified a new molecular pathway in the brain that directly links abnormal sugar modification in proteins to depressive behaviors. Specifically, chronic stress disrupts sugar chains or glycans attached to proteins in the prefrontal cortex, thereby triggering depression. The findings published in Science Advances open new possibilities for targeted therapies for treatment treatment-resistant depression. Depression arises from a complex interplay of psychological, environmental, and genetic factors, and many different pathological mechanisms have been reported. However, most antidepressant drugs in clinical use focus on regulating neurotransmitters, especially serotonin. These drugs, however, benefit only about half of the patients and often cause side effects such as gastrointestinal problems or worsening anxiety. This limitation underscores the need to search for new molecular pathways in the brain beyond the neurotransmitter signaling. The researchers focused on glycosylation, the process by which small sugar chains attach to proteins and alter their structure and function. Glycosylation has been recognized as an important mechanism in various diseases, including cancer, viral infection, and neurodegenerative disorders. Among its forms, glycosylation plays a role in cell signaling and maintaining balance in neural circuits. Through its involvement in brain disorders, has only recently begun to be studied. Using high-performance mass spectrometry, the team first analyzed the glycosylation patterns in 9 brain regions of healthy mice and found that each region exhibited distinct glycosylation features. They then compared this with the brain of chronically stressed mice, revealing significant alternation in glycosylation in regions such as the prefrontal cortex. In particular, they observed a reduction in acylation, the addition of sialic acid to the ends of sugar chains, which stabilizes proteins, along with decreased expression of the enzymes ST3-GAL1, which mediates this modification. To test whether this enzyme is directly linked to depressive behavior, the researchers manipulated ST3-GAL1 expression in the prefrontal cortex of both normal and stressed mice. Suppressing ST3-GAL1 in normal mice caused them to exhibit depressive-like symptoms, loss of motivation, heightened anxiety, even without stress. Conversely, increasing stage ST3-GAL1 in stressed mice alleviated their depressive behavior. These results identified decreased ST3-GAL1 as a key molecular factor that directly induces and regulates depressive symptoms. Medical news at HBMS TV.